mirror, right? My shirt says Nirvana. If I look in the mirror, can I just read Nirvana right there in the mirror?
No.
No. How's it going to look?
On Nirvana.
Backwards.
It's going to say on, right? It's going to look backwards or flipped around. So that's exactly what we're going to see here with these triangles, all right? Let's take a look at MNO. Okay, who can tell me what are my coordinates here for point M? You combo, you got it, buddy?
-1 and 1.
-1, comma, 1. Exactly. Thank you, sir. What about point N? Who can help me with my coordinates for point N? Just to make sure we all know. Yeah, Lola. -2, comma, 4. Thank you. And then, Kayla, you got O for me back there? -4, comma, 3. Good. What am I going to put on the inside of this triangle here? A 1. It's my pre-image, I can tell because it's the only triangle there. And none of my points have what's on them? Primes, right? There's no primes, so I know this is triangle 1. I don't know why this says JKO. I must have been tripping when I did this. MNO. We're going to graph the image of triangle MNO after a reflection across the x-axis. So everyone take out a yellow and a pink highlighter for me real quick. So whenever we do a translation, we've got a certain direction and a certain number, right? I'm going 3 to the left, 4 up, 5 down, 2 to the right. Reflections are a lot easier in the sense that we only have 2 types of reflections. A reflection across the x-axis and a reflection across the y-axis. Show me on your arms real quick, what does my x-axis look like? Is it flat, straight up and down? Joseph, Akeem, what does it look like? X-axis? Yep, flat. It's the one going through. You see the little X right there on the end? That's my x-axis. I'm going to highlight that whole axis in yellow. Good morning, Jeremiah. So what that axis here represents is my mirror line. Okay? So imagine this little triangle is you, okay? And then you're looking into this mirror. Which quadrant is my reflection going to be in? Remember, this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Which quadrant would my reflection of this triangle be in? Ross says 4. Lola says quadrant 1. Quadrant 3. Well, this is my mirror line. So I'm going to show you kind of visually what we're doing, right? If I've got my triangle here, and I'm reflecting it over this yellow line, it's going to flip over onto the other side, like that. Did you guys see that? I'm going to do it again. Okay, if this is I'm going to put a little, here's my triangle MNO. It's flipping down over that yellow line. Right? Because if this is a mirror, my image is going to be on the other side of that mirror. Does that make sense? Okay. So here's how we're going to do it. It's really, really easy. Once again, we all know how to count. So we're going to go point by point. Just like with the bed frame before, we got to take it apart piece by piece. I'm going to start with point M. And I'm going to ask myself, how far away from that mirrored line is point M? How many boxes away is it? Well, if I count from this point to this line, how many boxes away is it? 1. All right? So point M is 1 space away from my line of reflection, which means my image point M prime is also going to be 1 square away. I'm going to call that M prime. Like I said last week, if I stand really, really close to a mirror, my reflection appears to be really, really close. If I step further away, my reflection looks like it's getting farther away, right? So M and M prime are going to be the same distance away from that center line, that mirror. Okay, it'll make more sense once we do it. Don't worry if it's not clicking just yet. How far away is point N from this highlighted line here? How many boxes down would I have to go? 1, 2, 3, 4. So N prime is also going to be 1, 2, 3, 4 spaces away. So it's not like a translation where I'm following the pattern. Oh, I'm going to go 5 to the right, 2 up, 5 to the right, 2 up, 5 to the right, 2 up. My numbers that I'm counting here are going to be different depending on what point I'm reflecting. If I look at point O, how many boxes away from this yellow line is point O? 3. 1, 2, 3. I'm going to go 1, 2, 3 more. All right. So now I've got these 3 new dots. I'm going to connect them together. And what do we notice about these 2 triangles here? Anything interesting? Yeah, Lola? It does look kind of like a 3D shape, yeah, because of those lines, for sure. Like some kind of trapezoid or something like that. Are 1 and 2, are these 2 triangles oriented the same way? Kind of not. Right? Orientation we talked about is like if I'm facing you and then I turn and face the other direction, I changed my orientation, right?
Yeah.
With a translation, I'm facing you. If I step to the side, I'm still facing you. I'm oriented the same way. But here we're not oriented the same way. We took this triangle and we flipped it upside down to map right there, triangle 2. Okay? Notice how in my pre-image point N is at the top, but in my image N prime is at the bottom. You guys see that? Give me a thumbs up if you see that. Okay. I appreciate those of you that are with me. I know it's Monday. I know we're tired. I'm also tired, but we got to get through. So I'm just taking it and I'm flipping it around. What are M prime's coordinates now? This little green point right here. What are those coordinates? -1, -1. What about N prime? Close? -2, -4. And what about this blue point O prime? -4, -3. Right? So look at these coordinates. I started out with these guys. I ended up with these. What happened from this coordinate to this coordinate? Did I change the numbers at all?
Yeah.
1, 1, 2, 4, 4, 3. 1, 1, 2, 4, 4, 3. No, I didn't change the numbers.
But you changed the if it was positive or negative.
I changed the sign. I changed if it was positive or negative. Did I change the x coordinate at all? No. -1 is still -1. -2 is still -2. -4 is still -4. So what coordinate did I flip? Or what coordinate did I change if I didn't change the x? The y. My +1 turned to a -1. My +4 turned to a -4. And my +3 turned to a -3. So what happened to the coordinates? The y coordinate flipped signs from positive to negative. Bless you. Which axis did I reflect this over? The x-axis or the y-axis? The x. So I reflected over the x-axis, but my y-coordinate is what changed. All right, that's what we're going to get into tomorrow. So again, just like translations, this is all just counting from dot to dot, but the way we're counting is slightly different, okay? Real quick, just to get through this vocab, triangle JKL is the blank of triangle J prime, K prime, L prime. Anyone remember what word's supposed to go there? Starts with a P.
Prime.
Prime. Great guess. Pre-image. Right? JKL is the pre-image of J prime, K prime, L prime. In the transformation above, which is called A, what are we doing? Not translations, but what's the title?
Reflection.
Reflection. Nice. Because of the way the figure flips, Again, if I look in the mirror with my shirt on, the script is going to be flipped backwards. So I'm flipping across the x-axis, which is a straight line. These two triangles are blank, meaning they're the same exact size and shape. Well, what term means the same size, same shape? You guys remember from our vocab chart? Kayla, you remember? Congruent. Thank you. And of course, J prime, K prime, L prime is the image of triangle JKL. And again, I don't know why it says JKL, it should say MNO, but whatever, you get the point. I gotta change that. All right, questions I can answer about that first little part? Okay. So that's what a reflection across the x-axis looks like. Now it's asking me to reflect triangle, this one actually is triangle JKL, across the y-axis. Show me on your arms real quick. What does the y-axis look like? Phaedra, yep. Billy, good. Z, yep. Straight up and down. I'm going to take my pink highlighter and highlight my y-axis right there. This one is a little bit better for us to visualize because typically when we look in a mirror, it's going straight up and down, right? I typically don't have mirrors on the floor and look down into them. I guess if you're at like a lake or something, you could see your reflection like that. But mirrors typically are standing straight up and down, just like my y-axis, okay? You guys ever seen Phineas and Ferb before? Yeah? What shape is Phineas's head? It's a big, fat triangle, right? So imagine here's like a mirror, and then here's Phineas. Kind of looks like this, right? It's kind of like, I don't know. Close enough. Okay, there's Phineas. Yeah? You guys see it? Yeah. Don't laugh. That's fine. It's quick. If Phineas is looking to the, is that to the left for you? No, he's looking to the right. Right? He's looking to the right. What direction is his reflection going to be facing?
Looking to the left.
He's going to be looking to the left. His reflection is going to look like this.
His head got bigger.
His head got bigger? Well, it's not supposed to. Right? So notice how his nose was pointing to the right, but in my reflection, his nose is pointing to the left. That's that flip that we're talking about here, okay? But I did this a little off. His nose should be the same distance from that mirror on both sides, right? If this is 3 feet away, then his reflection is going to be 3 feet away too, okay? So let's pretend this is Phineas's head. He's kind of looking the opposite direction, which doesn't help, but that's all right. I'm going to put a 1 inside of my JKL. What are my coordinates here for J? This top point up here. What are those coordinates? 3, 5. What about point K? Where's point K? You said what? 5, 2. Good. And point L? 3, 1. Got to be real quick with our coordinates now, like I said. Now this time I'm going to reflect across the y-axis. So what quadrant should my image end up in this time? 1, 2, 3, or 4? Quadrant 2. Because I'm going to take this triangle, I'm going to flip it over that line. In this case, this pink line. Right? If this is my triangle, and I were to flip it over this line, like that, it's going to end up in quadrant 2, and it's going to be pointing the opposite direction, just like Phineas with his little nose, or I guess giant nose, okay? So it's going to end up somewhere over here. If I want to figure out exactly where it's going to end up, all I got to do is count. I'm going to start with point J. How far away from the mirror is point J? 3 spaces. 1, 2, 3. So how many more spaces am I going to count past the mirror? 3 again. 1, 2, 3. What can I call this new point here? J prime. Thank you, Michaela. J prime. And what are those coordinates? Anyone figure out what are the coordinates there for that J prime point? You said what? 5, negative 3. Very close. Flip it around. Negative 3, 5. Okay. Everybody see how I figured out where J prime is? Yeah? No? Yeah? Okay. What about K? How far away is point K from this pink line? 5 spaces away. 1, 2, 3, 4, 5. How many more spaces do I want to count? 5 again. 1, 2, 3, 4, 5. Boom. What can I call this new point?
K prime.
K prime. K prime is at negative 5, comma 2. One more point. Point L. How far away from my mirror line is point L?
3.
3 spaces away. So how many more spaces am I going to count? 3 again. 1, 2, 3. And L prime now is at negative 3, comma 1. I'm going to connect all those up. Call it triangle 2. And we can clearly see that these triangles are the same distance away from this mirror line, just on opposite sides. In my pre-image, point K was facing the right, and in my image, K prime is facing the left. That's how I can tell that I've definitely flipped this around. What changes from my pre-image points to my image points? Any of the numbers change? Just like before, none of the numbers change. Phaedra, what does change? The negatives. What coordinate became negative here?
All the X's.
All the x's. So let's write off to the side my x coordinates flipped signs. So we'll get into the rule of reflections tomorrow. Something to note though is, again, when I flipped my shape over the x-axis, I flipped the sign of my y coordinate. When I flipped my shape over the y-axis, I flipped the sign of my x coordinate. Yeah, Lola?
What's going on with the next page?
What do you mean?
Look at the equations.
He said D. There is no D.
Oh yeah, you're right. Take a look at the second page. Let's change these letters here. Instead of D and D prime, we'll do A and A prime. Instead of N and N prime, let's do Z and Z prime. And then instead of M and M prime, we'll do Q and Q prime. My bad. Like I said, it's Monday. All right. So let's take a look. The most important thing you need to do is figure out, where am I flipping it over? Am I flipping it over the X, or am I flipping it over the Y? Okay. The number one mistake that
Across the y-axis.
across the Y. The number one mistake most of you are going to make on the worksheet is flipping it over the wrong axis. Even though you got your counting and your points all right, we got to make sure we're reading the directions here. What color did we highlight the y-axis in? Pink or yellow?
Pink.
Pink. My y-axis is going straight up and down. What quadrant should my image end up in? Well, what quadrant is my pre-image in right now? 2. Where should my image end up? What would you say, Kylie? Quadrant 1, exactly. I'm going to take this guy and flip it over this pink line. That's going to get me over here in quadrant 1. What are the coordinates here for point A? Coordinates for point A? No? Phaedra? Yep, -4, 3. put a little 1 inside here. It's my pre-image. Now I got to count. All right? If I start here at point A, what direction am I going to count? Am I going to count down or am I going to count to the right? Where's my mirror line? To the right of this point or to the bottom? To the right. Okay? How many spaces from this pink line is point A?
4.
1, 2, 3, 4. How many more spaces should I count past that pink line then? 4 more. 1, 2, 3, 4. Boom. A prime. What are my coordinates for A prime here? Yeah, you combo?
4, 3.
4, 3. Which number flipped in my coordinates? The x coordinate or the y coordinate? The x. The x went from -4 to +4. Even though I flipped over the y-axis. I'm going to keep counting. How far away is point B from my line of reflection? 3 spaces away. 1, 2, 3. How many more spaces do I want to count? 1, 2, 3. C is pretty close. How close is point C to that line of reflection? 1 box. So how many more boxes am I going to count? 1 more. I'm going to connect those up. Boom, boom, boom. Throw a 2 in the middle. There's my image. Triangle 2. All right. Quick show of thumbs. How easy is that sounding? Thumbs up seems pretty straightforward. I think I know how to count, Mr. Church. Thumbs sideways, a little bit iffy maybe. Yeah, you're going to do these by yourself. But real quick, in this next example, am I reflecting over the x-axis or the y-axis? What does it say to do? X-axis. Thank you. That's this guy right here. So what quadrant should this image end up in? The third quadrant. Should end up down here. Go ahead and count, see if you can figure it out, and then move on to example F as well. See if you can figure that one out completely on your own without getting started up. Okay? Sure. Go ahead and try this one, guys. Oh, you already got it. Nice job. Just make sure you label these guys too. And that Z's gonna have a little prime on it. This one looks great. Which axis am I reflecting over on this one?
The x-axis.
Where point to the x-axis one? Right here. So if this is my line of reflection, and this is where I'm starting, I'm going to be flipping over that line and ending up down here.
So it ends down here.
That's right. That's why I said the most important thing is reading which axis I'm flipping over. Looks great. Easy, right? When Lola comes back, yeah. Nice job. Looks good. Yeah, good job. Yeah, just call it. Or I did Z and Z. First come from Z. Nice. Good job, dude. That was good. So this one we're reflecting over X. Right, so it's going to
The A.
down. Yeah, just you can leave that one there. Just cross it out or something, and then count down the same way you did that. You can do it. Where's this guy gonna end up? You say which way? Yep. So start counting. Doesn't matter where you start. You start anywhere. Yep. Yeah, see.
Oh, no, I did. Yeah, I asked.
So for this one, since we're reflecting on the X,
On Saturday, and then on
this
Sunday.
guy. So Z is one space away, or one more space, and then X is 4 spaces away, so 4 more spaces. Just like that. Make sure you put the ones and twos in their triangles too.
Joseph, yeah. Joseph, what's my age? What's my age?
Did you get the second page? Did you get the second page? Daisy, can you grab that second page? It looks great.
No, you can just write the one. Yeah. So
Works. You see how Q is all the way up on the edge of my graph? Q prime should also be all the way up. Sorry, on the edge of my graph.
Can I have right here? I can't.
Sure.
You talk about this one, my black one?
Grab one of these.
Oh, you did this one. You just. I had to give that one back. So you know how you do a Z, right? You see how it's down in one space? Put it that way. Yeah, because you're reflecting it like a mirror. So you are reflecting. You see how it's down 3 spaces? That means you're 3 down. 3 spaces down the other way.
All right. If you're still working, go ahead, but we'll close this out so we can get started. Give me 1 second. Yeah. So I did see a couple people on example E reflect over the wrong axis, which is exactly what I said was going to happen. You have to make sure you're reading and identifying where you're flipping over. Okay? It's the same thing with translations. If I don't know how many units I'm going and in what direction, I can't do it, right? So I got to read. I see, oh, x-axis, this guy's going to be flipping downward. So x is 4 spaces away. I'm going to go another 4 spaces for x prime. Y is 3 spaces away. I'm going to go another 3 spaces for y prime. Z is 1 space away, so I only have to go 1 small space for z prime. Look how quick that is. Very, very fast, hopefully. All right. Point Z is at -2, 1. Point Z prime is at -2, -1. So it looks like my y coordinate was the one that changed here. All right. Give me a thumbs up if your image looks like this one in example E. Okay. And for those of us that did accidentally flip over the y-axis and end up in quadrant 1, at least we got that, out of our systems before we get to the homework. Okay. Example F, where am I flipping on here, the x or the y? Flipping over the y. So I'm going to highlight the y so that my brain can see exactly where I'm going to be jumping over. Right? Point Q is at 5, 1. How far away from this mirror line is point Q? How many boxes away is point Q?
5.
1, 2, 3, 4, 5. I'm going to go 1, 2, 3, 4, 5 more. Same thing with P. 5 spaces away. 5 more spaces. R is only 1, so I'm only going to go 1 space. And these should still be congruent. even though they're flipped around, they're going to be congruent. Right? When I look in the mirror, it's the same exact person in the mirror that's standing in front of it. Right? Phineas doesn't look in the mirror and see Ferb. Right? Phineas looks in the mirror and sees Phineas. So my image and my pre-image should still be congruent. If I see something a little wonky, something a little off, they don't look congruent, just double check and see what you did wrong. It's probably something small.